Hello everyone, I'm Aizierjiang. I will spend 5 minutes on our benchmark of federated learning and knowledge distillation for 3D point clouds and the evaluation pitfall it turned up. First, why anyone chains those two together at all? Point clouds drive robotics, AR, and medical imaging, but deploy a classifier where the data lives and two problems show up together. Privacy. The scans sit in separate clinics and can't be pooled, so you train with federated learning. Edge compute. A full PointNet++ is often too heavy for a portable scanner, so you shrink it with knowledge distillation. Chain them, federate, then distill, and you judge the result by one number, the student's accuracy. To my knowledge, few people had benchmarked the two together for 3D point clouds. So my question, does that number reflect the federated teacher at all? To answer it, I built a benchmark that pulls the two stages apart. Stage 1, in blue, 5 clients, each holding a disjoint slice of the label space, deliberately worst-case school, and a server running one of 13 federated algorithms to train a PointNet++ SSG teacher. Stage 2 in red, that teacher supervises a compact student, small PointNet 2 on a labeled proxy set, using one of 10 distillation objectives. Every configuration runs over 3 seeds, 504 standardized run, including the complete 130 pair grid on the clinical data. 2 datasets, ModelNet 40 classes, and craniosynostosis head shapes, a skull fusion condition, 4 classes, where privacy and edge deployment are real constraints, not conveniences. And first, federated training degrades sharply. On ModelNet 40, the centralized reference reaches 92.26%, the best federated method. FedNova only 76.32, a gap of 15.94 points. On the clinical data, it's wider, 75.83 against a 100% ceiling, 24.17 points. And the 4 server-side optimizers land near chance on both. Worse, the ranking flips. FedNova leads on ModelNet 40, but it's mid-pack on the clinical data, where FedProx leads. No single algorithm is robust to this kind of school, so the teacher is fragile. What about the compression step? Second, distillation does its job, as long as the teacher is strong. The student is 74.51% smaller, 5.65 megabytes down to 1.44, and about twice as fast at inference. 5 of 7 objectives match or beat the 92.44% teacher. But here is the catch. If the labels alone can reach the ceiling, you are not testing the objective, you are testing the labels. So let's put a weak teacher in front of those same objectives. Third, the pitfall. Every objective is the same loss in 2 halves. One copies the teacher, the other feeds the ground truth labels on the proxy set. WCE is the dial between them. Take a collapsed teacher scaffold at 8.5% on its own. Keep the hard label term and the student still lands near the centralized ceiling with logit MSE 92.94%. That's 84.4 points above its own teacher. Not transfer. The student just learned the proxy labels. Turn that dial to 0. Attention transfer, feature KD, and the student falls to 16.99%, tracking the teacher. With hard labels in the loss, you are not measuring the federated teacher at all. A ModelNet 40 curiosity, we checked on patient data. On the clinical task, we ran the whole grid, 13 teachers, 10 objectives, 3 seeds each. First, see that the six objectives with a hard label term recover from any teacher. At most 7.5 points of movement across all 13, and essentially no correlation with teacher quality. A Federated teacher frozen at the 25% chance level still yields a 97.5% student under vanilla KD and 100% under CRD. The 4 label-free objectives follow the teacher almost exactly, correlation about 0.99. Give them that same chance level teacher, and the students land at 25 to 27.5%, the teacher's own level. And that cross-entropy term is reusing the every patient labels Federation was supposed to protect. 3 things to take home. 1. Label School breaks Federated 3D training. 15.94 points below centralized model net 40, 24.17 on the clinical data. No algorithm fixes it. 2. Distillation compresses well, 74.51% smaller, about twice as fast. 3. Hard label distillation measures the proxy label, not the federated teacher. So evaluate these pipelines with label-free distillation, drop the cross-entropy term, or use an unlabeled proxy, and the number you report is finally about the teacher. Benchmark, code, and every checkpoint are up here. And that's the talk. Thank you very much. I'm very happy to take any questions, and feel free to email me or directly log in, directly visit the page to have a confab with me. Thanks.